So we're doing problem 15.18. What we have is we have a weight attached to the end of a 1.5 meter string. And what we're given is that the weight of the string is 0.0125 newtons, and that the tension in the string is equal to the weight of this mass. And we're also given that when plucked, the waves obey this equation here. And so the first thing that we're going to solve for is we want to know how much time it takes a pulse to travel the length of the string. So to do this, we're going to use two different equations. We have that the velocity equals the angular velocity divided by k, and we know that the time it takes is equal to the length of the string divided by the velocity. So to solve for the velocity, what we're going to do is we're going to take our angular velocity and our k. And so this right here is our angular velocity, and this is our k value. So we're going to plug those in. And so we get velocity equals 4830 second inverse over 172 meter inverse. And what we find is that our velocity is 28.08 meters per second. And now we're going to take this value and plug it in right here. So we get the time equals the length of the string we know is 1.5 meters. And we're going to divide that by 28.08 meters per second. And we get that t is equal to 0.0534 seconds. And so in part B of the problem, we're trying to find this right here, the weight of W. So to do this, we're going to start with this relationship, and that is our mass per unit length equals the mass of the string over the length of the wire. And so rearranging this, we're not really rearranging, solving for the mass of the string. We know the mass of the string equals the weight of the string over gravity. So we get the mass of the string equals 0.0125 newtons over 9.8 meters per second. And we get that the mass of the string is equal to 1.2755 times 10 to the negative third kilograms. So from there, we can plug this back into this equation. And we get our mass per unit length is equal to 8.5034 kilograms per meter. So from there, we're going to plug them into this other equation, where we're going to get that our tension is equal to the velocity squared times the mass per unit length. And we know that our tension is equal to the weight there. So we can plug that in. And what we're going to get is we get 28.08 meters per second squared times, I made a mistake right here. This is times 10 to the negative fourth for our mass per unit length. And we plug that in right here. And we find that the weight is equal to 0.67 0.05 newtons.